Hello guys, welcome back to Mr. Cloudbook channel. Today is the day 50 of the Kubernetes Masterclass, and in this video we are going to learn about the Kubernetes certificates. So why we are talking about the certificates and everything? What is the use mainly? So Ajay used HCD and you provided some certificate paths and took the backup and everything, where it schemes and everything. We have to understand why we need to use the certificate. Actually, we have to learn the concept of certificates. Okay, so why SSL certificate is needed and how this everything like Kubernetes API will talk with Kubelet, HC like Kube API will talk with HCD, like that, right? Everything you need to understand. I will try to do my best to give the simple way of why we need to use the certificate. So imagine you are at a school and only students and teachers and staff are allowed to enter. Okay, so simply, so this is the school I have. So only the school students, staff, only these three people can allow. Some rare cases, what we can do, we can allow the parents as well. Okay, student parents, that is up to us, so we can allow them as well. So this is the simple school to make sure the only right people get in. Okay, so only here what we will do, we will allow the required people. Okay, so like we will allow the students and teachers and members and only staff members. How to identify them? First of all, student gets the ID cards. Okay, so whenever the student joins the college or the school, we will provide the simple ID card. Okay, so what happens? So here student joined, I provide one simple ID. Okay, for him. This is its identification. Next, we have the staff members. So these guys also will be provided with different ID card compared with the student. So same like, so we have the different guys that are teachers, like that other stuff. So we will provide each one with different ID cards. Okay, teachers have the special ID card, school has its own ID card, badge and approval and everything. So each school has one trusted organization certificate as well. Okay, so why do we need these IDs? So let's think about another few scenarios. What if someone pretends to be a student and sneak into the school, right? So I have one student here. He's not from this school. Okay, he's tried to sneak in without any ID card. So what if we don't have ID cards? So anyone can join, right? Anyone can enter the school. Anyone can do anything like teasing the girls or like anything. We can broken some benches like that. Some rowdy boys will do that. Okay, no problem. So what if strangers walked into the classroom and saying they are the teachers without teacher ID cards, right? That is also another issue. The school can't know the if they are real teachers or not. So someone is joining. So I am the new teacher here. People will allow him if we don't have ID card. Yeah, that is also possible. So here students can go if they don't have ID card. We are not providing any kind of certifications like, right? So we are not giving the certificates of ID. So anyone can come inside, go outside whenever they want. So IDs are like the trust system. Okay, they ensure that only the real students can enter and attend the class. Only the real teachers can teach. Okay, so here I have the ID card, so I can enter easily without any issue and complete my studies here. Okay, I can read, I can write and everything. Play games whenever the playing game. So here teacher have the ID card, so he can teach. This is the simple way. So these are the certificates where we need it. Okay, like so I am explaining in simple ID format, but each server needs the certificates to talk with the other things in a secure way. Okay, how does this relate to the computers? Now, instead of a school, imagine a Kubernetes cluster, a group of computers working together that needs to be only let the right people like admin using the kubectl. So I have the Kubernetes here. So each Kubernetes cluster will get the config. So everyone has one config. See here what happens, only the admins can run the kubectl command. Kubectl create, delete. So they have only access to create and delete. Okay. So other dev guys will get the access like read pods. They can only see the pods, okay, list the pods, okay, nothing else they can do. Okay, they can delete, they can't update or anything. That is not possible, okay, if you are not having the admin access. So we will create a different kind of certificate, okay, different kind of config certificate, what is called certificate signing request. There are so many things we have to learn in the Kubernetes, so we will talk about it. So only the admins can use the config which is having the full access, okay, using the kubectl access it, okay. So only let the missions like worker nodes to join the group. So I will use the kubedium join command, right? We will use it kubedium join like that. So only the exact matched people can join the cluster. Ensure every communication between the pods of the system is secure and no outsider can eavesdrop. Okay. So what if there is no secure between the pods? So anyone can check the data. This application is using 1 debit code. So if it's not secure, hackers can use the data, right? That is one of the issue. So we can easily access the database system backend and everything. That is one of the issue. A simple example of certificates at work. So let's imagine a conversation between the two friends. So here in this school, okay, needs to exchange the private notes. Okay, Alice and Bob. These are the two students. Alice. Okay, we can call it as the A and B. Simple formats we can understand. So here B wants to talk with the A. Okay, Alice says, "I hello B." B says, "Hello A." That is how it will work. So A checks Bob's badge. Okay, this particular A guy will check this particular B guy badge. Okay, before talking. Okay, this guy is our school or not. Okay, before sending some notes. Okay, this checks. Okay, this is our school ID and this is verified. Okay, so second person, what B will say, he will also shows the identity card because they need some kind of identification, okay, to prove his identity. A asks B in order to send some notes to him, his identity. So B shows it in order to prove his identity. So here this particular whatever the nodes going the transaction between these two guys, okay, is secured with kind of one of the key. Okay, so here A has the encryption key and B has the decryption key. Only B can decrypt that particular message and can read that message. Okay, without someone capturing that particular notes. Even if it's catched by the someone else, what will happen? They don't open it because only B has the access for the decrypt of that particular notes. Okay, this is the decryption key to open this particular message. Okay, so when B only provide this description key to your particular secret notes or whatever, so then only he can read it. Okay, this is where certificates are needed. Okay, so this is how it works, certificates also. So now nobody else including the classmates or strangers can pretend to be a Bob, read the notes because we are having the decryption key, encryption key, some kind of certifications, proof of identity, IDs like that, right? So what happens without IDs? If Bob didn't have ID, Alice wouldn't know if it's really Bob or not, okay, if it's B or not. So someone else could read the note, steal it, or write back pretending to it's a B. Everything would be a mess completely if we don't have the certificates and everything. So how this works in the Kubernetes? In Kubernetes, A uses the admin like kubectl, B uses the Kubernetes API server. Okay, here A is the kubectl, B is the API, KAPI. Okay, main control server. Their conversation sending the nodes, okay, between them like kubectl, get the nodes, add this one particular thing, do that particular secret, keep it this secret and everything. So will happen between this A and B. Okay, so A is kubectl, which is admin, and B is the Kubernetes API server, which is the main control center. Their conversation is like more secure way. Okay, the certificates act as the ID here. Okay, Pro identity. So kubectl knows it's talking to the real Kubernetes API server, not to the some imposter here. Okay, encryption is the communication. First, we have to encrypt the communication so no one else can read or change the information while being shared it to the Kubernetes API. Okay, certificate makes sure everything stays private, secure, and trusted. Okay, this is why we have to use the simple certificates and a simple summary. Prove who you are, keep your private conversations safe, only allow the trusted people to interact with the authentication. So in Kubernetes, certificates plays the crucial role in the ensuring the security of communication between the various components and resources. They are primarily based on TLS, means transport layer security, and are used for securing the communication, authenticating users and components, and encrypting the sensitive traffic. Let's deep dive into the detailed structure. We will see in a simple way what is the purpose and generation using these certificates in the Kubernetes straightforward manner. Okay, what are the certificates in the Kubernetes? Certificates in Kubernetes are X.509 cryptographic documents. So use it to authenticate, encrypt communication between clients and servers within the communication cluster. They work in the conjunction with the public key and cryptography methods like TLS to enable the secure communication. So if you don't know what is this X509, you can read it from here. X509 certificates. Okay, if you come here, X.50 certificate is a digital document that verifies the identity of a user or a device or a service. It is used to secure communications and transactions over the internet. So what it contains? It will contain a public key for certificate subject, a digital signature from the certificate authority CA that issued the certificate, information about the certificate subject such as their name and organization, how it will works and everything. The public key is used as the encrypted message. The digital signature verifies that the message was sent by the certificate subject. The certificate subject can use the public key to establish the secure communication with another property or another party. So where it's used and everything, how it's managed, you can read it from here. So you can read more X.509. This is important if you want to learn more about it. Okay, authentication service. You can use the geeks for geeks. That is up to you. Next, what we have to do. Each certificate includes a public key. Okay, here let's talk in a simple way. What happens? Each particular certificate includes the public key, and next one, a name, common name, and possibly some extra identifiers like subject alternative names like CN, SANS, subject alternative names. Okay, this is the another property that contains the certificates, and a digital signature from the certificate authority CA. We already saw in X.09 CA, and validity period. So we have the validity period, and the next, what else we have? Finally, we have the optional extensions. Some extensions will be provided that are optional. OPT, that is optional. So where certificates used in the Kubernetes? First of all, certificates are primarily used in two ways. Okay, so how many ways? I was explaining in a simple format. Two ways. What is it? Certificates are primarily used in two ways, which is to secure cluster internal components. So first one is internal. So int, that is simple one, internal components. And second one, to secure external access. So here internal means such as Kube API server, kubelet, etcd, like that. External access means like kubelet, kubectl access, API server, HTTP access. Okay, so I will explain in a simple way. Okay, Kube API server, secure communication between API server and clients. Also use it to communicate with the cluster components like kubelet, etcd, etc. So here we have the Kubernetes API server. Okay, which talks with the kubelet, okay, in order to create the worker or sorry pods on the nodes, worker nodes using kubelet. It will communicate always, and next it will communicate with HCD as well, right? Because it will store every data whenever you change, update pods and everything. So this needs the certificates, okay? These are all needs the certificate. Mainly we need the certificate for the Kubernetes API server, which communicates with the cluster components like kubelet and HCD, such as more services. Kubelet also needs some certificate. Kubelet uses its client certificate to authenticate itself with the API server. Okay, it uses the client certificate. Next one, HCD. HCD uses a certificate to secure communication between its peers and the API server for data transport. Remember that. kubectl, we use that one. User facing CLI tool uses the certificates like token based authentications to securely interact with the API server. That is the other one. Control manager scheduler both uses certificates to authenticate with the API server. And ingress controller we will talk with later uses certificates to terminate TLS traffic from the external resources and forward some request and everything. How certificates are structured? Each certificate is often paired with one private key. Okay, the structure of a Kubernetes certificate is typically consist of these files. Okay, so we have the certificates for the Kubernetes contains structure. So first one is .crt. This is the public certificate, and second one is .key. So there will be a different name at the starting. That's why I'm providing .key. So these are all private keys, okay, and validate the data. And next one we have the CSR key. Okay, I will show it. Know what it is. So CSR means it's optional because certificate signing request use it to request the certificate from the CA. Okay, how Kubernetes certificates are organized. Okay, a root certificate authority. First of all, we have the CA, right? Root certificate authority, CA. A central trusted authority that signs and issues the certificates for us. Okay, we will get CA.certificate like this, CA.cert, CA.key. So we will get two keys, two certificates. Okay, next we need the server certificates. Second one, server. So first CA is done, next we will need the server. So here issued to cluster components like API server to identify themselves. And next we have the client certificates, HCD certificates separately managed by the secure communication. Kubelet certificates used by the worker nodes. Okay, how certificates are created and obtained in the Kubernetes. Certificates in Kubernetes are usually managed in two ways. Automated certificate management with Kubedium. So mostly we will use Kubedium. Everyone, even in the CK exam as well, they will use the simple Kubedium. Okay, so what is the structure of this one? Okay, we will see. Kubedium is a command line tool for setting up the Kubernetes cluster. Everyone knows it. So it will certificates automatically generated and stored under this particular directory. So and if you go here, so if you go to the killer code, I think yeah we have the access. So if you go to /ct etc and if you see ls, yeah, there are so many folders will be there, but we have to go inside the Kubernetes because we every certificate will store here ls, and you can see that pki. Okay, and if you use say, let's say try tree pki enter. Okay, tree is not found. We can install it by using this command apt install tree. So we can see the certificate structure as well using the tree command. So it will take some time. So how it will there, I mean like how it will store and everything, we use a .csr, .crt, .key, right? So we need to check everything. Okay, that is done. So what I'll do is I will go inside the pki as well, and here I will use tree enter, and you can see that. So we have the different certificates. Okay, API server HCD client .crt, which is public one, and they have the private key. These are all for HCD. You can see that API server HCD client and HCD private key, API server ones. So these are all for keys for HCD. HCD have the different folder, that is etcd, and CA certificate and CA key, health check, peer certificate and peer key, server certificate and server key. Okay, these are all needed. And you can see that API server kubelet certificate, client certificate, API server certificate. So these are all, these two for API. Okay, these two are for API and kubelet, and these two are for API and HCD. CA is for certified authority, right? So these are all, and proxy keys and SJ key, service authentication keys and everything. So these are all simple structure. Okay, so kubelet and everything, you can read it from here. So when using the Kubedium, certificates are valid for 1 year by default, after which you may need to renew them. Okay, so these are all created by the Kubedium automatically, but these are only valid for 1 year. Remember that. Manual certificate management. So certificates can be manually created using the tools called OpenSSL and CFSSL. These can be created using the OpenSSL. These are all created by manual. So till now we talked about the Kubedium. So let's go back to the main server. Actually, manually create the certificates. Admin generate a certificate signing request. First of all, we have to generate a CSR, and then we will need to sign it with the CA, and then we have to issue the certificate. Additionally, Kubernetes has a CSR certificate API for requesting certificates from the Kubernetes built-in certificate authority. We have it. How to configure the certificates and everything. API server. Okay. So, and if you go here, cd/etc Kubernetes manifest, enter. So we will talk about first API server. So we will see ls. This is the kube controller, kube API server, right? Cat kube API server, enter. And if you see here, and if you go up, they have the different ones. See, so this will talk with everything. Okay, see HCD. So we have the HCD CS certificate and HCD certificate file and HCD key file. So in order to this particular API server talks with the HCD, we have to attach everything: service account, SCA public key, SCA key, TLS certificate, TLS private key. You can read it from here. Kubelet client, because HCD needs to, I mean API server needs to talk with kubelet as well, right? So each one should be managed there as well. Okay, kubelet also needs the same certificates and everything. So we have the HCD. So and if you clear it, and each one provided here, okay, cat hcd.yaml. So they have the certificates for this one. Okay, see that certificate file, HCD and HCD server, HCD peer key, HCD peer certificate, CA certificate, CA key, like that. So everything will be provided here in /etc Kubernetes and manifest. In API.yaml, we have to use this one, static pods. So renewing the certificates. So if you want to renew the certificates, okay, so create the scan. You can come out of it. And if you want to renew the certificates of Kubedium, you can use this one, Kubedium alpha certs. Yes, I think this one command, certificates renew all, enter. So this is not found, unknown command. Okay, sorry, it's I gave the wrong command. Alpha, it should be alpha, enter. Okay. Okay, this is Kubernetes experimental subcommands. Okay, this will regenerate all the necessary certificates, and we can check it here as well. So Kubedium, come copy, paste here and enter. So certificate management with the Kubedium. So if you check here using the custom certificates, you can use this one as well. So external CA mode and everything. If you want to read more about it, okay, auditing, C group and everything. So you can check this one, okay. Kubedium sets check expiration. So by default we will get 1 year, I think. Yeah, let's see. So this will expire on June 2020, January 2026. See, 1 year only we are getting everything, all certificates expiring. So CA certificates will get 10 years. Okay, you will get 10 years for this certificate authorities. So for remaining certificates, you will get only 1 year. Remember that this is the simple command. Kubedium sets check expiration. This is the easy command. Okay, so client certificates, and you can read these all if you wanted to. Manual, and you can see that Kubedium sets renewal. We can just copy this and enter. So you can see that. So reading the configuration from the cluster and certificate serving and everything. See, done renewing the certificate. You must restart the Kube API server, Kube control manager, and etc. So that is up to you. You can check again, but it will show the January 31st. Last time we have 28, right? So this will be different. Okay. So that is how you can simply renew all the certificates using the simple command, that is this one. So if you get the question from the certificates, mostly you don't get, you can check it. Okay. So it will check this particular command, whatever, it will check the mismatch also. Okay. Each one has the one different service. Okay. The main thing is that is simple. So set up a signer, you can add the signer here as well. So to renew the certificates, external CA and everything. So read it from here if you wanted to know more about it. So and if you want to see CSR, okay, CSR enter certificate signing request. So why we need the certification means proper and secure communications. Okay, this is the simple concept. You can read it from here. Okay, see that. So we are creating the cluster role CSC creator. So what we are creating, create, get, list, watch. We are giving access to only required permissions, not to everything. So we will see this in the upcoming sessions as well. I hope you understand about the Kubernetes certificates. This is the certificate, API signers and everything, approval, rejection, how to approve the CSR and everything we will see in the upcoming sessions as well. Okay. So thanks for watching the video and keep on supporting to Mr. Cloudbook channel.